When we want to evaluate an integral, we're thinking about the antiderivative. And the antiderivative is tricky if we try to just look at all the y's right now, because there's a 2y up top, there's 2 plus 3y squared inside of parentheses, and then that's being raised to the third power. So if there's a lot going on, that probably means we want to make a substitution to figure out what that antiderivative is. Because the goal in the end would be to use the power rule in reverse. Right? If we had just something like u to the third, then we could use the power rule in reverse. We know that we'd have u to the fourth for the antiderivative. That way the 4 would come down, get reduced by 1, and we'd have to have a 1/4 out front to make sure that there's no coefficient. So that's what's needed here. U substitution isn't really an exact science, you just have to do some guessing. So I'm going to guess that it's the inside of this parentheses. And let's see what our du is, because we need to have both. We need to have a u and a du after we're done our substitution, and then every y has to be substituted too. So we take a derivative of this with respect to y, that's 6y. I've almost got my du in the numerator, which is where it's supposed to be. I can finish getting a du by putting a 1/3 in the outside. That means I can multiply by 3 on the inside to give me 6y in the numerator. So in terms of u, du in the numerator, like we wanted. And then 2 plus 3y squared, that's u. To the third power. And since it's a variable in the denominator, we can rewrite that as u to the negative third, and then du. As long as we're not putting in the denominator, we can just write it off to the side like that. So the antiderivative of u to the negative third is going to have a power of -2, because when we take the derivative of this, we want to turn it back into u to the negative third. So when you take a derivative, the -2 comes down, multiplies, then it gets reduced by 1. But right now, this derivative won't equal this term up here. We have to put a -1/2 out front. That way, when the -2 comes down, multiplies, it cancels out. Because whenever you find an antiderivative, you want to make sure it matches what you have up here. And since there's no limits of integration, there's an infinite amount of different equal solutions for the antiderivative, so we want to add that constant c in there. So this is -1/6, and we can put it back in terms of u. It's u to the negative second, so you could say u to the second on bottom, plus c. But instead of writing u to the second on bottom, let's put it back in terms of y, 2 plus 3y squared. And that's to the second power, right? Because it's u to the negative second, so this is u to the second power in the denominator. So there's our answer.